Today we're going to be learning about complex fractions. Now a complex fraction is a fraction, but it's a fraction that has fractions inside of it. An example of a complex fraction we see right here, a over b over c over d. Now I see three fractions here. One up top, a over b, one on bottom, c over d, and then a big one, a over b over c over d. This is the complex fraction. Now the most fundamental definition of a fraction is division. That's numerator divided by denominator. If we look at a regular fraction, let's say x over y, this is equal to the numerator x divided by the denominator y. Now a complex fraction does not differ from that definition, except now the numerator is a fraction itself, a over b, and the denominator is a fraction itself, in this case, c over d. And we learned before something about dividing fractions, which is called keep, change, flip. That is to keep the top the same, keep the numerator the same, keep the first fraction the same. That is change the division to multiplication, and that is to flip the second fraction, flip the fraction that follows the division sign. And again, this is following the definition of a fraction and the process of dividing fractions. So let's start with number 1 here, which says 3x to the 6th over 2y to the 4th. So that is 3x to the 6th power over 2y to the 4th power divided by 5x to the 2nd power over 9xy to the 4th power. Again, this is the definition of a fraction, which is the numerator divided by the denominator. Now, because this is fractions being divided, we can keep the first fraction the same, 3x to the 6th over 2y to the 4th, times 9xy to the 4th over 5x squared. Cross-canceling is going to allow us to reduce this x to the 6th with this x squared and have a remaining x to the 4th. Cross-canceling is also going to allow us to reduce this y to the 4th with that y to the 4th. And it looks like nothing else is going to reduce. So then our answer will be 3x to the 4th times x, 9x, over 2 times 5. And we can multiply this together to get 27x to the 5th power up top and 10 on the bottom. This is our answer. Another one here. Numerator is a plus 8 over 7 divided by the denominator 64 minus a squared divided by 21. And this is going to equal, let's put it down here, a plus 8 over 7 times 21 over 64 minus a squared. Now in order to finish reducing, because that's the next step after you turn this to multiplication, reducing means that we have to factor first. So 64 minus a squared reduces to 8 plus a and 8 minus a. This is the difference of perfect squares. So what's going to cancel out here? A plus 8 and 8 plus a. These are equal because of the commutative property of addition. That means a plus 8 is equal to 8 plus a. Those are the same thing. Now, if there was a minus sign in between there, that is not commutative. But what we get left is 21 up top and 7 times 8 minus a on the bottom, and we're done. A couple more examples to do. This one has is a little bit different because the top has two separate fractions and the bottom also has two separate fractions. So in order to do our keep, change, flip, our definition of a fraction kind of thing, what we need to do is combine like terms, not combine like terms, but we need to add or subtract these fractions up top so that they are singular in nature. That would be an LCD of 44 on the numerator, and that would be an LCD of 12 on the denominator. So what we're going to get here is 5 over 11 times 4 plus 31 over 44. Again, multiplying the first fraction by 4 over 4. 11 over 12 minus 2 over 3 is the denominator, and this needs to get multiplied by 4 so that those denominators are the same. So on top we have 20 over 44 plus 31 over 44 divided by the denominator, which is 11 over 12 minus 8 over 12. So 51 over 44 over 11 minus 8, which is 3 over 12. And now we have a complex fraction with a single fraction up top, a single fraction on bottom. So we can now translate this into a division problem through our definition of a fraction. 51 over 44 times 12 over 3 is our new operation. So at this point we can cross cancel. 12 and 44 both divide by 4 to become 3 and 11. 51 and 3 are reducible by a factor of 3. That would be 1 on bottom and 17 up top. So we're going to get 17 times 3 over 11 times 1, which is equal to 51 over 11. And this is our final answer because it does not reduce any more than that. Let's look at this one. Let's give ourselves a little bit more room to work with. And we have here a fraction up top, which is 35 over 1 minus 6 over 7x. Again, there is an over 1 here that is not written down, which you can write down yourself. Our LCD is going to equal 7x. So there is our LCD, which means that 35 over 1 is going to need to get multiplied by the complete 7x on top and bottom. On the denominator, I see an LCD of 35x. So 7 over 1, we're going to multiply again top and bottom of this other fraction, 7 over 1, by the complete 35 over x. So let's go ahead and do this out. 35 times 7x is going to equal 245x over 7x minus 6 over 7x divided by 6 over 35x minus 7 times 35x is 245x over 35x. So since these are not like terms, they don't actually subtract, but they do combine into a single fraction because the denominators are the same. So 7x is that denominator. Same thing with the bottom here. 6 minus 245x is equal to just 6 minus 245x. But we can combine them into a single fraction, which will allow us to put this as a division problem. Like so. Which will also allow us to keep, change, flip. 245x minus 6 over 7x times 35x over, this should be 6 minus 245x. Again, we are flipping the second fraction. So something kind of unique happens here, which is that 245x minus 6 minus 245x are not exactly the same, but because they are reversed with the subtraction sign in between, they do cross out. In this case, they cross out to be a -1 on top and a 1 on bottom. 7x crosses out with 35x, and you're left with 5 on bottom. So -1 times 5, sorry, -5, you're left with 5 on top. -1 times 5 over 1 times 1 is equal to a whole number, -5, and that's our answer. Last one. LCD is equal to t times t minus 7. LCD over here, t minus 7 and t is equal to t times t minus 7. Again, finding the LCD here is the same as adding and subtracting rational expressions, right? We're only allowed to multiply. T minus 7 and t are separate, completely separate, unique factors. So this is our LCD. So 4 over t times t minus 7 minus 7 over t minus 7 times t divided by 4 over t minus 7 times t minus 7 over t. This is times t minus 7 on top and bottom. Right, so everything's got to get multiplied by something in order to make this match. And we're going to get here 4 times t minus 7 over t times t minus 7. Leave that in factored form. Minus 7t over t times t minus 7. 4 times t over t times t minus 7 minus 7 times t minus 7 over t times t minus 7. Now, again, look at here. We did not do this multiplication. Leave it alone. We did not do this multiplication. Over here. Leave those alone, okay? So 4 times t minus 7 minus 7t divided by t times t minus 7 over 4t minus 7 times t minus 7 over t times t minus 7. Combine them into single fractions on top and bottom so that we can translate this into a division problem. Divided by 4t minus 7 times t minus 7 divided by t times t minus 7. Keep, change, flip. So we'll get 4 times t minus 7 minus 7t divided by t times t minus 7 times t minus 7 divided by 4t minus 7 times t minus 7. That was a lot of writing, but we do get to cross stuff out now, like this t times t minus 7. Can we cross out the t minus 7 here and here? The answer is no, because we got these minus signs outside parentheses, right? So we can cross out the entire t times t minus 7 on top and bottom here, cross cancel that. But we can't really cancel anything else, so that means we just have to move forward with this rational expression, 4 times t minus 7t up top, 4t minus 7 times t minus 7 on bottom. Again, nothing here is going to cancel. We are going to distribute to reduce this rational expression. So 4t minus 28 minus 7t divided by 4t minus 7t minus 49. Negative 7 times negative 7, that should be a plus 49. So we got like terms here to add up. 4t minus 7t is negative 3t minus 28 divided by negative 3t plus 49. Now it looks like maybe you can cancel these out, but again, the presence of a minus and a plus sign outside parentheses, really simply put, forbids that. Maybe there's a GCF you can factor. There is not. Over here, there is not. And since nothing factors, then we're done. This is our answer. Negative 3t minus 28 over negative 3t plus 49.